Tonight, we're pleased to welcome Bob Tegtmeier to Sperry with tonight's program, an inside look at Sperry Rail Service 1999 to 2000. Most rail fans know the Sperry Rail Cars inspect the rails, but how's it done? Bob served as Sperry's Quality Assurance Manager in 1999 to 2000 and was able to ride the cars doing inspections, help qualify new vehicles, and learn about the non-destructive test methods used to detect the multiple defects that occur in the actual rail. And he took photos. The program will give an overview of Sperry Rail during that time, along with a bit of history and the structure of the company. Bob was born in the Bronx and grew up in Yonkers, so subway rides, watching the New Haven in New York, later Penn Central trains, were a big part of his childhood, but it did not stop there. After getting his bachelor and master's degrees in mechanical engineering, he discovered there were railfans and model railroaders at his aerospace employer in New Jersey. He and his friends have been building and operating model trains and rail fanning together for the last 45 years. We did not ask Bob whether he's a Yankees fan, but we'll kind of assume with his background he probably is, but we forgive him for that. So Bob, welcome to Sperry.
Oh, thank you. Thank you very much. Yeah, born in the Bronx. I guess I may have to be a fan, but no, it's I want to thank everybody for coming out and listening tonight. And I've done this program a couple times, and well, people thought it was interesting. So, well, I hope you all enjoy it. And it was fun putting this together. So with that, you want me to start sharing the screen?
Whenever you're ready.
All right. Well, let's see if we can find our presentation to share. Okay.
That looks good.
Looks like I'm sharing the screen. Yeah, Dave was kind enough to make a suggestion to improve the title, so I guess it really sold itself. So yes, I worked at Sperry Rail from 1999 to 2000, and certainly it was a good time for me. Like I said, I've done this a couple of times. This program actually was done with a bunch of railfan friends back in 2000 or 1999 or thereabouts. I actually got the people to come into Sperry and see the big cars, so quite a treat for 10 or 12 people. So some people said yes, they'd be interested in hearing this, so okay, here we go. So anyway, as you said, yeah, I was hired as a quality manager with an engineering background and a quality background, love of trains. Boy, this should have been the perfect job. Again, a lot of this information was used in the customer presentations. I did the presentations. Tom DeJoseph, my boss, a good friend at the time, and still a good friend. He did these presentations for the railroads, CSX, TFM in Mexico, Florida, East Coast, UP, just to name a few. I learned a lot from Mike Shakinovsky, who was the non-destructive testing level 3 in the company. And I even worked with Mike after I left Sperry. He's an amazing guy in the world of non-destructive testing. Dr. Robin Clark was our design engineering manager, and we shared a lot of this information. We both did presentations, and he would take pictures from me. I would take pictures from him. It was a very good relationship. Alistair Veach, also from England, he was the driving force behind Sperry Rail 200. You'll see that soon. So Robin, Alistair, myself, we put a lot of presentations together in PowerPoint while I was there. I got the opportunity when I was in the shop. We were on Shelter Rock Road in Danbury. Been there for years. I could walk out my office, make a turn, and go right in and see the shop. So I could go see the shop people. I went out to help with suppliers and things like that. So I was grateful for how well they treated me. So I'm not an expert on the operations today. I know a little bit. I've made a few updates, but this will give you some idea of how the company works. Again, my employment ended in May of 2000. I found out that when you don't make your EBITDA, the people who own the company in Greenwich can do whatever they want. But it was fun while it lasted. So the first time, like I said, when I did this for my friends, I called it a ferroequinologist presentation. And yep, it was back in January 7th, 2000, and I've made a few updates. So when I started, Rockwood Service Corporation owned Sperry Rail, and they were into material testings, inspection, non-destructive testing. They were doing pipelines and all sorts of inspection. So there was Longview and CanSpec and Hellier, who was Chuck Hellier, is one of the godfathers of non-destructive testing. They had his name, and Sperry Rail Service. You know, they were able to provide a lot of non-destructive testing to clients throughout the world, not just the railroad, but Sperry was always on the railroad. So this is how it was set up in 2000, 1999, 2000, when I was there. So Sperry was around for quite some time. Back in 1928, there's a picture of one of the first cars that Dr. Elmer Sperry, who holds over 400 patents. I think he's only second to Thomas Edison. He was contacted by the railroads after there were a number of terrible train wrecks. Hey, how can we inspect the rail? So he started it, and he started doing it with induction testing. So Sperry's been testing since 1928. These numbers are a little old. It said we tested over 10,000 miles of track. Well, that was back in 2000, and they detected 5.5 million defects. So I'm sure that there's a few more. But well, why is this important? Well, because if you don't detect the defects in the rail, as you know, well, things like this and like this, these are actual Sperry derailment pictures. And this, and this, you know, when the rail breaks, there can be trouble. So Sperry Rail Facts, as of 2000, this is what they said. They're the first, this is what they sold, the first company to provide the railroads with rail detection service. They were the world's largest, and I'm sure they still are, the world's largest rail inspection. Now they've got over 90 years of rail flaw detection. They had 58 vehicles when I was there. I went through the numbers. I could never find out what it is, but when I would look at the literature, it said, yes, they had 58 detective vehicles. It was over 50. One of the things that somebody said to me, says, Bob, what's ASNT when you say what's 100 qualified ASNT operational staff? These are the people that would actually do the rail verification on the cars. And they were approved by the American Society for Non-Destructive Testing. And at the time, they were the only company totally focused on rail flaw detection. Pandrol Jackson would do it, but they had other things with Harsco and things like that. But Sperry always focused, or Sperry Rail always was focused on rail testing. So Tom DeJoseph really liked how I did this. I'm not going to tell him how I did make that happen. But rail is the most expensive track asset in the railroad industry. And of course, rail being expensive, well, you know, you can get defects. And those defects can come from the internal defects can come from the steel making process, from fatigue, number of ways that you can get these defects. And this is my tough attempt to see, as you'll see some of the defects, that was my drawing of some of the defects there. So one of the things, what causes the rails to break? Well, you got the vertical loading, flat wheels pounding on the rail, temperature. You've seen the rail kinks, it goes both ways. It grows in the summer and it shrinks when it's cold out like it is tonight. That's all putting stress on the rail. You can have excessive wear, corrosion from engine burns and things like that that can destroy your track. Poor maintenance. You think about the railroads back in the 30s and 40s, in the 20s, they always had track section gangs, and everybody was tightening those nuts on the rail joints, because if the rail joints are loose, you're going to crack. And then, of course, then there's the internal defects from manufacturing. In the world of rail making today, it's less and less, but you can still have internal defects from manufacturing. So what are these rail flaw defects? Well, if you take a look at the visual representations, you got transverse defects, and you can see those are in the head. You've got horizontal defects that can occur in the web. You can get web cracks. You can also get horizontal defects in the head. You can get vertical defects. You see this one here is in the web, but you can get vertical defects in the head. And we'll see some pictures. Web defects, you can get star cracks, you can get cracked webs, piped rail, bolt hole defects. Funny thing, when we were in the Danbury Railway Museum, I had a picture of one of these cracked rails, and apparently Sperry must have given them the actual rail that was taken, that they took a picture of. So we had the actual rail along with the picture as part of my presentation. And of course, now that we've got a lot more welded rail, you can get weld defects. You wouldn't have had those back, in the early years because it was jointed rail, but certainly weld defects are things that can happen. So transverse defects, well, there's one. This would probably have grown from that little pinpoint from a defect, and kind of like tree rings, as this thing would grow, you would detect it. So there's transverse fissures, compound fissures, detailed fractures, reverse detailed fractures. These transverse defects, as you're going along with the rail, they are usually at a 10 to 20 degree incline against the flow of traffic. Something like this obviously is a big problem. We would measure these things ultrasonically and find out how big they are. You could, if you found a small defect and it was within guidelines, you wouldn't have to remove the rail or the piece of rail that had the defect. This one, yes, the rail probably broke, and that's why it's there. But you'll measure it over time as you continue to inspect the rail. Well, a horizontal split head. Well, that looks like a horizontal split head. It's pretty well defined. Again, you can have them in the web, which would give you a cracked web, but that's an actual split in the head. Vertical defects, a vertical split head. So there's a section of a split head, and this particular one is right in the middle. This was taken on the Sperry Rail test track that was in Danbury, and you can see how it's just broken right through. When I was out in Pennsylvania riding on one of the high rail vehicles, we had the track out. There was a big vertical split head. Well, we shut the railroad down because, first off, you're on the track, but then they actually took the track out, replaced the rail that day because there was a vertical split head, a vertical split head that ran quite a number of feet. Half of the head of the rail could have fallen down while the train was going over it. So we got web defects. So as you can see, there's a cracked web going through there. And that's a piped rail. The only time I've ever seen a piped rail was this picture, but apparently it did happen. And so, yes, you can get your defects. And then we were talking about the bolt hole cracks. Something I only found out when I saw a presentation last Wednesday over at Danbury. They were talking about what induction can do, and induction will not detect bolt hole cracks. I didn't realize that. Obviously, induction focuses, and we can talk about it a little bit, focuses on the head of the rail, but the ultrasonics give you all the good pictures of what's going on below the head. So, weld defects, well, if you've ever seen them do the welding on a rail and they're doing the thermite, it gets real hot. You make usually a very good joint, but you can get as you can see in that picture there. Oops. Sorry. You know, you can have porosity in your welds. With weld defects, you know, this is what happens with the weld. The failure obviously occurs before you can see it. They do grow very quickly once they develop, and service failures result, as you see, in a complete break on the head, the web, and the base. It just usually goes right through. Well, now you've seen some of the defects. How is it detected? Well, the induction method is a surface and subsurface railhead. That's what Elmer Sperry brought to the table back in 1928, putting a current into the rail and using a coil, checking to see readings when there were discrepancies. So if there was a defect in the head or in the rail where there was a break, you would get a squiggle on it was a paper tape, and you would have to go back and verify that, yes, there really was a defect. So the induction was around in 28, still used today. Ultrasonic inspection was newer. Sorry, my bad. So ultrasonic inspection is also pulse echo, it's called. It's non-invasive, cost-effective, and this is what really gives you the picture of what the defects are. We're going to see a little bit more about how that's done. And again, these are all non-destructive test methods. You can certainly break rails and say, oh, yeah, it's got a defect, but you can't do that when the rail is down, when the track is down on the ties. So again, induction was the beginning. Harcourt C. Drake was the patent holder for Sperry. He's the guy who took Elmer Sperry's information and put it in the patent applications. And again, it was just energizing the rails and then detecting to see if there was a defect in it. Eddy current inspection would be very similar to what you're doing the induction method of rail detection. And some of the original cars that they used back in the 30s. And ultrasonic testing, Tom DeJoseph mentioned the other night that it came from Germany. I don't know where the RSU or the ultrasonic testing, if it really did come from Germany, but they started it in 1959, according to Dr. Robin Clark. The hand testing was started in 1949, and you'll see when we take a look at the transducers, you'll see why ultrasonic testing was a much easier way to find defects. What this here is, it's just showing you an RSU on a rail and these different transducers are checking for, as the pulses go in the rail, they're checking for an echo to go down and back. If the echo doesn't match the way it's supposed to be, well, then you got to go take a look and see if there's a defect. On the big cars, you'd normally have two ultrasonic roller search units, and you'd have the induction right next to each other. So we're going to see a little bit more about that too. So when you're going down the track, you can inspect both rails at the same time. And you can see that there's a lot of defects that you can find. The only thing that you can't find is a broken base. But chances are, if it's a broken base, the rest of the rail's intact, it may not be too much of an issue. And again, I just found out the other night that the induction testing did not detect bolt hole cracks. So, and that's interesting because they were testing rail and jointed rail. Now you can inspect the rail joints without removing angle bars because ultrasonics will do that for you. The other thing that rail inspection does, they give you a permanent record going back to the 20s and 30s and 40s and 50s and 60s and 70s, probably to the 80s. They would use paper tapes that would indicate what the defects were, and then they would record what the defects were all on paper. Once computers came in, they were able to use computer screens, in fact, on the tubes, not just the what we have today with the flat screens, and they could record the defects, and they would record them and have a permanent record on a computer. So that was really a big thing that was going on in 1999, 2000. But they have the largest rail defect database in the world. This is a very, very busy schematic of what goes on. But basically, you're going to put a pulse out every 1/6 of an inch on the RSUs, checking down, shooting down, and coming back looking for a defect. You're going to have an encoder that you're going to set to the milepost monitor so you know where you are. And that way you've got location information. The RSU, the roller search unit, which is the ultrasonics, well, that's going into channels along with your induction signals. They're all being processed through at the time, 20 channels of signal processing. Okay. And you had two types of roller search units. So you could look straight down into the rail, and you could also just do the head. All this information would be fed into a defect detection system and control system. You would get your data storage. This would give you your report generation. You would take a look at real-time displays. Even when you were doing the paper tapes, it was real-time display, but you could have it on the computer. And the other thing that would happen with all this is Sperry would have a track marking system that would shoot a glob of paint that would mark the defect, so that when you went to go see, well, where is this defect? I've now rolled past it. Now I got to go back up and verify this defect by hand. Well, how do you find it? You look for the paint splotch. So this is a better picture of what the roller search unit looks like. Dow made the tires. They're filled with ethylene glycol. There would be water that would be sprayed onto the rail as couplant, so that the transducers that were shooting into the rail would go through the ethylene glycol, through the tire, through the rail, and then come back and shoot back. And that's what limited your speed, because the pulse of the echo going down looking for a defect, well, it's got to come back, and it's got to go through all these different fluids and rail. So if you went too fast, you would miss your return signal. So this, they called it the Omni RSU. It had a 0-degree transducer looking straight down, so I could see if there was any defects in the rail horizontally. They would have 37 degrees, which could catch your bolt hole cracks. And then they would have 70-degree transducers that would look straight into the rail and catch. You saw that one nice transverse defect? Well, you can see how that would shoot and pick up that transverse defect that's at 10 to 20 degrees to the rail. So this is the Omni RSU. Well, they also had a DF RSU, and this was a 70-degree, but if you take a look at how these are set up, it's actually looking to the side of the rail. It's not looking straight on. So this is another way that you would shoot a pulse echo in, and if you had a horizontal crack in the head, or it would be another way of detecting any of the different head defects, where most of the defects do occur. And then Sperry got really clever and came up with a UX9 RSU, and that combined those two roller search units, all those functions into one. So you had 3 70 degrees. The limiting factor on these, how many RSUs, is if you didn't have enough capability in your electronic boxes, you couldn't use some of these different RSUs. So it was specific. If you had an older car, you might not be able to use a UX9 RSU, roller search unit. So when the operator is going down the track, well, this is his visual of a rail joint. So he looks out, and you'll see some pictures of a very handsome fellow demonstrating this. As you're going down the track and you're looking, you see a rail joint, and that's the operator visual. Here he's going to see the rail joint. Well, what he's seeing on the analog equipment, and this would be much more similar to what a paper tape looked like, your induction line is in the middle, and you're going over the bolt hole joint. You're getting a squiggle. Now, I don't know induction. I can't read these things. I'm amazed at the people that can, but I certainly can take a look and say, oh, look, 1, 2, 3, 4, 5, 6. Well, there's my 0 search unit looking down and actually seeing every one of those bolt holes. The other ones could be the 90, could be the 37. Those are more of the responses that they're seeing analog wise, and they would see this. But what they would do initially for the digital response is, well, here, we've cleaned it up. So we've gone from your analog meter, where you're seeing your, go back to your, when you were tuning up your cars, or, and you're reading what the points dwell is and things like that. Well, this is the cleaned up version. This is the equipment response that they would see now. So that's the digital equipment. And they would be able to mark on the computer screens if there was a defect. Well, how did we get there? Well, they tested with rail-bound vehicles like 138, and gee, does anybody recognize where this is? You don't have to answer, because it was up in Boston, and this was the car that I was riding in. And you could also go on high rail vehicles, and here we're out in Pennsylvania. That's Amtrak coming down on the middle division, and this is SRS 804. And I'll just tell you a quick story. When you go out on the rails, you have to have somebody from the railroad as your as your guide, as your, your interface with the railroad. They always come on the car or the truck as the the person to make sure they got clearance, and hey, it's their railroad. Somebody's got to be there. So this one particular fellow, this is coming downhill, and this train was making pretty good time. We're all by the 804, and the guy, 24 years with Conrail, whatever, he's walking down the middle of the gauge. And because it's downhill, he doesn't hear this locomotive. So we're all yelling, hot rail, and then he turns around and looks, and it's like, oh, so you have safety manuals for a reason. Sometimes people have a little, they forget. So we're glad that we were there to yell hot rail for the guy. So how do we do our testing? Well, we've got rail floored vehicles that identify defects before they fail for the most part. So you got the 100 series cars. Those are the big cars that we all grew up with. It's the one the model that I have behind me. There's also that's a Sperry drawing behind me of the big car. They had the 800 series back then. I'm talking 1999 to 2000. The 800 series was an induction car, and they were Fords, and then Ford chassis, and then they were Sterlings, and Sperry built these cars. The 200 series was a big car that got shipped over to Norway. It was state of the art. You can actually see it's here in Danbury, and we'll talk about that. And then you had what they called 300 series. This was your hand testing, doing small industrial tracks when you didn't need a whole detector car. So your 100 series, 145, I believe that went out when I first got there. Boy, it looked gorgeous. But at the time, it was the only dual test system with both induction and the RSUs, the roller search units. So they called them complementary systems, and they were. You could do 13-mile-an-hour testing. You could run 50 miles an hour light speed. One guy said he had it up to 55, but 50 was what they said they could do. These cars had living quarters in them. Some of them had bunk beds, some of them had individual bedrooms, but there was a big demand for these up in Canada, where there were not places for you to hit a Motel 6. So again, they had the induction, they had the ultrasonic. Now I'm going to go into chase car technology. Before I go to that, right here, there would be, when you would do your hand testing, the car would have to back up to where the defect was. There would be an ultrasonic reflectoscope here, and you would bring the car to the defect and do the testing. So that was stop and go, stop, back up. You use your buzzer systems. So Sperry came up with chase car technology. And what chase car technology was remember, you painted where the defect was, and you would have an encoder telling you where it was from the mile marker. So what would happen is you would have the chase car come down behind you, and they would do the verification, so you would not have to do a backup move, get off the car, get back on the car, go, it was just eliminating the stopping of the detector vehicle. So now, using the radio, they could transmit the data to you from this chase car. He would do the down on the ground, checking the defect by hand and sizing it and making sure that you knew what was going on. Today, the results can be uploaded to the cloud with the GPS locations. This is what I read. So this was a way of increasing the efficiency of your cars. And you could do this with both the high rail trucks and with the big cars. And in fact, sometimes they were built in, the trucks were built together with, when they were commissioned, they were built with the truck and the chase car. So it really provides for a much better way of doing your testing. Now, the 800 series, originally they start off as Fords. These were the high rail vehicles. They could run, well, easy on and off track. We'll show you a picture of that. Again, limited to the 13-mile testing, and they could run 30 miles an hour on the track. You had these Fairmont rail that went down, and your driver wheels would actually run on the rail. So it's like, yeah, you know what? 30 miles an hour. When we were doing 30, it was fast enough. So, but you could run at normal highway speeds. You could leave the tracks at crossings, and they had the ultrasonics, and you usually wound up in a Days Inn or something like that, Motel 6. You wanted to save your money, I guess, when you're out on the road. But you would drive to the motel, and you would drive down in the morning, and you would get on the track where they wanted you to get on the track. And most of these had the electronic strip chart. As all the ones that I saw had the electronic strip chart. I don't know if they had any paper tapes. So, again, this is just talking about the chase car verifications. And it always seems to be the same 40 to 50 miles per day that you're expected to get from testing. It obviously will vary with how many defects that you have or what kind of interruptions you have with the railroad. But if you're modeling these things and you want to inspect your track, you better plan on having your main line taken out of service for a while, because unless you're a 2-track main or 3-track main, you're not getting around these vehicles quickly, and they're not getting off quickly. So in 2000, this was the 900 series high rail induction cars, and these were, for the first time, and I'll show you some pictures, they were actually adding ultrasonics or adding induction testing to the high rail trucks. This one was the very first one. I saw it being built in Danbury. So now, where you could only get this in the big cars previously, now you could use the induction method. You can see the brushes there. You can see the detector. That's what was here in this test bed. The other thing that they had with the high rail, and I drew this from a PDF. I was so proud of myself. Tom still doesn't know how I did it, Tom DeJoseph, but well, he hasn't worked there almost as long as I haven't. They had a much clearer picture of what the defects looked like. So when you take a look and you see your bolt holes and you see a defect and you see the rail joint, you start to see here that, oh, wow, I'm looking at these defects more as a photograph than as an indication. So that was B-scan imaging, which was just coming of age when I was there. So 901 was being built. Here we are in the shop. You can see that the Sperry shop was had a rail, 2 rails down the center, and you could have multiple cars stacked up in there. But this was the very first ultrasonic and induction car. So this was the hype that, no other rail testing offers these features. Remember, induction is more complementary if I'm testing rail, I'm relying on RSU. But it was the first one was available July of 2000. Well, I left in May, so I can't tell you if it was there. So it had the dual testing methods. It had the induction, the B scan, and of course, nonstop operation, chase car, and that was available in 2001. Were these numbers and dates correct? We'd have to ask Tom. I don't know, but it's still 40 to 50 miles per day. Okay, this is the 200 vehicle. This was actually made in the shop. They welded the structure, but it was either 147 or 148. They used the chassis for that and then dropped off this beautiful new vehicle on top of it. But it did have a lot of amazing stuff that it can do. The processing allowed it to go faster. Physics wise, I still don't know how they could do it as fast as they did, but they could go faster and test, the high speed marking systems. They could test in both directions, which the big cars, you only tested in one direction. You had the front of the car and then you had the back of the car when you were looking out. So you're always looking at the rail as it was going by. This would test either way. So this was pretty unique. And 75 to 100 miles. Now, what did they get? I don't know, but I know that car has been over in Europe, and it really, apparently they did quite well in Europe. But it was a beautiful car, and I remember Tom DeJoseph, when he christened it, he said he never expected to see another big car built at Sperry Rail. Well, they built one more. I don't believe they built any more after that. But it was a beautiful car. The walking stick, you can see that it's got a roller search unit. It's got couplant on it. It's got a reflectoscope. It's got handles, and boy, is it ugly. It would fold up and put it in a backpack. You could, do crossovers or something where you didn't want a car going across, industrial track. And I know they updated this picture because this was pretty ugly. I don't think you'd be selling a lot of that stuff. So, hand testing. Okay. The hand testing units, again, here you're doing testing on an industrial rail. What you're seeing here is you have a search unit, and you're looking at this bolt hole, and you're seeing, oh, there it is. Look, I've got a bolt hole. I can see this defect. So somebody's looking with a 0 degree, looking straight down, and he can see it. So these were new Kraut Kramers. They were liquid crystal displays before you had, like HP oscilloscopes. You had electrical displays. Oh, wow, look at this. It's light. It's portable. It froze when the temperatures went to 0 degrees and you couldn't use it, and they had to pull out the old reflectoscopes. But when it was warm, these things were wonderful. They really worked very well. But this is an example of what you would be doing when you found a defect in the rail. You'd have to test it by hand, and you could test it with a 70 degree. You could test it with a 37 degree. You could test it with a 0. All these different ways of testing rails, because you had to size these defects when you found them. So anyway, this was just the hand testing. And then, of course, the Sperry 403, which I know we're waiting to see this come back to Danbury. But this tested a lot of the New York City subways. It was the replacement for 402, which was also a Mack rail bus. And when we would go in the subway, you would just drive on the rail. You never stopped. You never looked. They would take a look and read all the tapes the next day to look for defects. So there's that modified Mack rail bus, the front and the back. And again, there were 10 of them by the New Haven got back in the late 40s, I guess. They never really went into service. They went to Remington and hauled gunpowder and around the shops down in Bridgeport. And this is the inside. This is the neural net. This is the B scan. This was the first very new processing that Sperry had. But when they were, and again, these were Mack rail buses, Remington Arms used them to transport gunpowder. When they got these from Remington and they were making these beautiful rail vehicles, you can see them here. Well, the gunpowder bags sometimes leaked. And when they were cutting and welding with the torches, somebody got a really big surprise, and I believe there was an underwear change involved after it with the flash. So just one of the stories that were handed down. This was a very cool car to ride in the subways, though. You really got quite a view of the stuff. So how do we do our testing? Well, with the 100 series, the 200 series, we got to travel by rail to get there. 800 series, and then of course the 900 series, you would just hop onto the rail wherever you needed to do it. I showed you how we would check indications by hand. Now, I know it looks like he's lifting it on there, but he's not. He's parked the car on a grade crossing and he's lowering down the Fairmont trucks to go into the rail. But the first time I took this picture, when I said, what the heck, is this guy trying to lift this truck on there? No, he's actually lowering, once he's on the rail, he's lowering the Fairmont wheels. And here we are. Yes, it's SRS 804, some custom lettering that they did. But here he's actually going down and he's checking that rail to make sure that whatever was seen up on the screens that he had is really there. It wasn't a false indication. So when we find them, we got to mark them. And then the railroad takes over and decisions are made per FRA guidelines. Once you find a defect, if it's too big, you have to take the rail out. If it's small, you can let it grow and check it the next time you come through. But here was a rail defect from a burn, and it got marked, and I still don't know what they were marking a DHS, what kind of split head it was. But that was marked. And it's not unusual, if there's a problem, to see the rails removed the same day and the new ones put in. So we actually did see them remove the rail, and then they came out and welded the new piece in.
Bob, I do have a question I thought I'd throw in right now.
Yeah, go ahead.
So the question is, person who asked says, I always assumed the test car was also measuring track alignment and track gauge at high precision. Not so?
Not so. Not the Sperry cars. They talked about putting in video systems and adding that to get a vehicle that did more, but their focus was on rail. A lot of the cars that you see in Trains magazine or the new cars, yes, they're measuring gauge, they're measuring ride characteristics and things like this. Sperry at this time, I don't know if they've added these features since, but their focus was finding those defects in the rail. Sound good?
Fine, thank you.
Okie doke. So what else does Sperry do? We've got we've covered a lot of the rail inspection, but they actually made their vehicles or had them made. So here is the 200 being fabricated in the Sperry shop. And this was Alistair Veach's baby. It was quite impressive. They had people come in and do some of the welding, obviously, but that was the structure that was dropped on the chassis. And Alistair did the design. He did everything. Amazing fellow. I watched them commission 826, 827, 828, 829, and 200. I didn't actually participate in it because this was an engineering thing, and I wasn't sure what was going on, but it was really cool to go sit in, and they had really nice, comfortable couches and wonderful air conditioning. And of course, they maintained these vehicles. They had facilities out in Kansas and some other places, other shops that would do the work. But 145, you saw a picture of it earlier. Well, this was when it came in for refurbishment. And when I say refurbishment, I mean, these cars really got refurbished. And, the windows were out, everything was redone. And well, this looked gorgeous by the time they finished it. And that's actually on the track in, outside of the shops in Danbury. And I forget, a number of them were named for old time employees. So they did, they had a lot of technology. They had technology development. They did test simulators. They came up with the chase car inspection. They came up with high rail induction. Neural nets, I still don't know what they are, but I know that's what we were selling. So, I have a vague understanding of what neural nets were. How they worked on the railroad, I'm not sure. And of course, new testing techniques. So there were your neural nets. And man, if he can't sell a test simulator, that was me like 24 years ago, when my mustache had color in it. And what I'm doing is I'm posing. But what this guy is doing, this was their test simulator. So they would have a track that was simulated like video games today. And then you would get the indications on the screens. And you would use this pen here. You would actually do the recordings of what the indications were. And this way you didn't have to mark it on a paper tape, and this would all be downloaded to a database. And there I am demonstrating the pen. So this is how I made it into the presentations when Tom would do these presentations for the railroads. But it actually was a very good way of training somebody. Rather than having to spend time looking over the shoulder on a big car, you could do it on a computer screen. So field investigations, when there was a problem, well, Sperry had a department of 6 rail investigators that reported to a manager of field investigators that they would go out. If you had a problem after the rail had been inspected, well, they expected somebody out there, and what happened? So they were on call, especially after accidents. And sometimes the Mike Shakinovsky, he would also be called out in cases of big defects. So they responded on site. So you can see there's the picture. There's the defect. And well, now you guys are experts. You know it's a transverse defect in the head, and the rail broke. So what would happen is a thorough review would be done on site and of the Sperry test records. Remember, they have the largest test database, defect database in the world. They know where everything's been done. The paper tapes go back to the 20s. So they can check this stuff. And this is the information that the operators would be filling out by hand, which is why they probably liked doing it on the computer, so they didn't have to do all these types of defects. I never saw somebody fill these things out, but obviously somebody said, yes, I measured, here's a defect here, it's this big. Okay, well, I think we're up to like 55 minutes. And then there would be copies of the computer printouts that they would go through and inspect them. So the railroad got the whole story, the good and the bad. And this was an actual report that was done. It actually went to somebody in the director of rail and testing, and it was from Carlo Patrick. And he tells them what was right, what was wrong, what happened. We talked about collecting data. Well, one of the big things that Sperry was doing, there was a lot of access database programming going on, but they were looking to make reports. They were looking to put the defects in so that they could easily be found, develop software to say, hey, you know what? You want to check this the next time it comes out. So you can see that there was specialized reporting and data transmission to the client. This 1999, 2000, well, that's kind of cutting edge of sending emails and everything else and sending this stuff. The web was starting to be used. So yes, so the business support and development people, they would verify the data integrity. They would do the daily car production data reports. They would send them out. There would be monthly statistical reporting. I'll show you something in a minute and what it looked like. And, they would design stuff so that people knew where their defects were and what they needed to do about these things, all only trying to make things more efficient and more productive using the computers on their data. So this is a report that went to some railroad that we can't see because I blocked it out, but I know who it is. What's interesting is, I don't know how much you can see, but they said, well, there were 22 service days. They tested 17. The average miles of tested was 23 miles. But if you look, you'll see 20, 31, 22, 23, 29. Here you had 57 miles of being tested in 9 hours. Well, hey, I think they hit their numbers. But this also reported the number of defects during the day. So you got a complete story of what was done. How many times did the car have to stop? So if you take a look right here on 1/3/2000, they had to stop 29 times. Now, if you're not running with a chase car, that means the car has got to back up at least 29 times to go back and verify a defect. So you can understand why having the chase car comes in handy. Yep. Yeah, that's my notes. This went to CSX. That slipped. They also had an ultrasonic training school, which was open to the railroad personnel by invitation. It's also how they train their folks on NDT in Danbury. Mike Shanofsky taught it. It was 4 days of classroom and 1 day of testing where you actually had to do the test and pass everything. And all those defects that you saw, well, they had examples of it and you had to find these defects. So here's the rail and we don't know what the defect is. This guy's going to take his transducer and he's going to tell us what it is and he's going to tell us how big it is and what kind of defect it is. And obviously it was open to women also, but you can see everybody's testing rail because you've had your classroom stuff, so you understand what this is. Now it's actually the function of going on the rail and finding the defects, which is what the operators would do on the big cars and the high rail vehicles. You had to get 10 out of 12 correct to pass the test. Okay, and there's only one person that got all 12 right in my class. And that person took 3.5 hours longer than anybody else. I think I was there till 9 o'clock at night. I couldn't become a level 1 because I didn't have practical experience, but the training was so good that I was able, never having done this before, just having ridden on the big car, I could actually tell you every defect that was hidden in those rails because of the training that they gave you and what you could do with the Kraut Kramer and the search units. So I was pretty pleased about that. And I used ultrasonics later after I left the Sperry, or after they left me. Rail testing standards. Sperry would work with the FRA and, there hadn't been set calibration standards. They developed them. They were the ones that would tell the FRA what the smallest detectable defect was. They would work with them. Of course, once an indication was recorded, it had to be verified. That's why you had to stop and go. It was always a defect unless it was verified. But this was the stuff that Sperry worked with the FRA so that they could develop their standards. So I must have had to be doing something other than getting my friends in and riding the rails. I only rode the rails a total of about 7 days in the 2 years, but hey, that was pretty cool. So I was trying to get Sperry into ISO 9001 compliance or 9002. So I wrote their quality policies and Tom liked it. And, this is what we told the customers. You know, I wrote the updated safety manual. I helped formalize the cheap operation evaluation procedures, trying to get this so that, well, after we left, somebody else could do this. It was just trying to get a lot of the stuff that people knew, but never had time to write it down. And of course, then it was just making sure that we had the people doing the testing. But why would I update this safety manual? You may be surprised by the answer. We'll go over that. So, the usual BS that, I believed it at the time, trust me. But, continuous improvement. We had our quality policy, which was required. I actually copied it from a solenoid valve company that I worked. I just changed this Honeywell Skinner valve to Sperry Rail Service and put things in like the world's railroad. But, this was the stuff that we needed to do to get ourselves ISO registered. And Tom DeJoseph did back me up. He and I wrote up the quality policy and explained it to the people and why it was important to them. So this is the Sperry part where Tom would be doing the getting up to the closing, where growth oriented, international, we're into high-speed testing, chase car technology. The neural net keeps coming up, and high rail induction. So this was where Tom would be closing, when he was doing these presentations, that would be the stuff that would be flowing in there. So I added a few things. And when I came to Sperry Rail, I was an expert at PowerPoint. And this was, Tom DeJoseph went down to Florida East Coast to sell them on the railroad. What was the biggest, the most important thing that happened for the president of the railroad? He took a look at this cover and he said, "Where did you find this Florida East Coast Railway? Where did that come from?" And Tom said, "Well, I contacted the railroad and said, 'Can I have this for the presentation?'" I don't know. Tom said he didn't know if the president paid any more attention to the rest of the presentation, but that Florida East Coast thing, I think that sold it, because I went out and said, "Oh, that'll look great on the cover of the presentation." And of course, then there was the original one for CSX. And this was the first one that I had done, that Tom went out and I got him all set up. And he was going against Pandrol Jackson, who was also in Danbury. And I talked to him on last Wednesday, or when I saw him, I said, "Tom," I said, we got you all set up. You had this, he had an Epson projector. I had all the wires set up so he couldn't possibly fail and to get this presentation there. He said the Pandrol Jackson guys went in. They had 5 guys and a couple of overhead, sheets that they put on a projector. Then he came in his suit and did his presentation. And he said to me, he says, "Bob," Ron Bright was one of the guys, I'm sure. Because I said, "Tom, how did it go? How did the presentation go?" He says, "We got it. They said it was the most professional presentation they'd ever seen." It's like, well, boy, was I on cloud 9. That's why I threw this in here, because it's like, well, Tom, I had just talked to Tom about it. And well, it was a very big moment for me. So Sperry Rail Service, a technology company providing service for over 70 years. I'm now the Tom DeJoseph mode again. Owned by Rockwood. Sister companies involve non-destructive testing. We share in resources. Poised to grow. And grow it did. In 2002, Rockwood bought the competition, Pandrol Jackson, also located in Danbury. So they actually grew the business and doubled it in size. So it was very amazing. I asked Tom about this. He says they put that together very quickly after I had left, but 3 to 4 months, they had this this done. So I have a couple of pictures here, and I'm gonna this is the big cars. This was 134 in the yard by there. I'm going to blow these up a little bit, but I'll just quickly say that this is the operator view. This is the front of the car. This is the back of the car. This is your 1970s technology for those big cars. You did have a kitchen. This is the paper tape that would go down, and you would have that tape just roll and roll and roll. You had wonderful recreation facilities, and I did not sleep in a bunk car. So they had bunk cars and they had bedroom cars. I got to go in the bedroom car. This was Sperry Rail 200, all their publicity pictures. I think they took a bunch at the Danbury Railroad station, now the museum, Railway Museum. And it was built on chassis 140 of SRS 147. They scrapped the body and put this on there, and of course put the information, all the new stuff on it. But it was certainly from the ashes of 147. This 149 car, that's a picture that you saw in the behind Dave. I'm going to talk about that. There's a story behind it. 810 was in a rollover. You can see that was a problem. This is 138. I think we're in Middleborough. Is that one of the rail yards on the MBT? The guys, we were out on the train, and we stopped there overnight. Sperry would always talk about, hey, you get to see the world. Yes, you certainly get to see the world. That was in Montana. So Reuben Fairchild took that picture. Okay, so I asked about the safety manual. So here I was driving by in the Bronx. That was taken down next to the Harlem River, and 149 was there, and it was next to the third rail. And one of the guys, he says to me, "What is that?" I said, "Where are you from?" He said, "Iowa." I said, "That's third rail." He says, "Well, I shouldn't touch it." I said, no, I would recommend not touching it. So I checked the manual, and they addressed overhead catenary, not a thing about third rail. And these guys are testing in the subways. That's why I wrote the manual.
So first of all, one of our attendees has looked up neural net on Wikipedia. So it's used for, among other things, pattern recognition, signal analysis, and 3D reconstruction. Presumably this referred to the more modern displays that look like a picture of the actual defects.
There you go.
So then we've got a few questions in here. Thank you, Lucius, for that comment. Michael asks, did the railroads use the historical data that SRS saved to spot locations of high levels of rail failure?
Well, like I said, what they would do is they would know where the defects were that were not removed. And obviously this is where, if they were getting repeat failures, that's where they were looking to use the computers to say, look, at this location, you're getting constant cracks and problems. So that's what Sperry was trying to do with the information that they had. But they had many years of paper tapes, all in libraries and cataloged and whatever. I'm not sure how much the old stuff was good for, other than if they got a rail break and they knew that there was a defect there and they didn't test it often enough, then the stuff would hit the fan. So
Next question. When did the Sperry shop leave Danbury and where is it now?
I went past the shops a couple of years ago and saw they were empty. I know they have an office building in Danbury, and they supposedly have a shop in Bethel. They did have shops out in the Midwest, but I don't know if they still maintain them. Pandrol Jackson, they just had a test track in Danbury, so I don't know what happened with the Sperry test track, which was over there because it was loaded with defects, and you'd have to ride to with the truck to or the big car to make sure you could detect all the defects. That was your final test that you would ride on that test track. So I'm not sure where they are, but I am told they are in Bethel.
Okay. Michael asks, did the 901's induction unit trailer fold up for highway operation?
Yes, it did. Yes,
Okay.
it would fold up against the truck, and it had a cover. And I've seen that they've now incorporated some of them where they actually have a case that will close up for a highway truck.
Mhm.
But that was the first one.
Okay, so Walter asks two questions. First of all, any Y2K software issues since you were around during that time? And then secondly, were there false positives? In other words, indication of a defect where there actually was not one?
Oh, yes. So Y2K, we survived. Nothing happened. We all waited, but there was no impact on the business. For the false indications, yeah. Sometimes there would be false indications. That's why everything was considered a defect until you went and hand tested them. And that's where you would check and make sure. A lot of times we would stop, can't find anything. They would record it. So if the next time they went through, if there was an indication there and it got picked up, they'd know, oh, well, crap, we didn't pick it up last time. Maybe it was so small that they couldn't find it. A good operator, he would find the defects in the rail. But that's why everything had to be verified, because yes, there are false positives, whether it was loss of contact due to the couplant not making the contact between the tire and the rail. Yeah, there were that was, we probably had more. When I was checking, there were more false positives than positives.
Really? Okay. Move on to the next question. Do the inspection cars only operate during daylight hours during clear weather? Do the inspections take place on more than a 5-day week? And person adds, thanks, great presentation.
That's one of the things you might wind up working weekends. It's when you could get track. You might go out on a day and only test for an hour. You're still getting paid, but they couldn't get you track time. That's why you always had a guy on the car. I don't know that they tested much at night. I don't remember anybody telling me that they were doing testing at night, but in the short days of the winter, maybe they did. I don't know. You were usually out on the car for a couple of weeks if you were rail bound. So you would wind up with extra time off. I actually have that I need to get converted. I have a DVD that says stepping on board with Sperry Rail Service. Unfortunately, I have not been able to convert it from VHS to DVD, but that's something I want to do. And they talk about having vacation and time off, and what life is like on the big cars and what it's like when you're out on the high rail vehicles and you're staying at Red Roofs or Ramada Inns. Is always three guys to a crew, and if you had somebody that had to leave, they would send somebody out to take your place. So
Okay. You may have just answered a question. It's a little further down here. The questions are pouring in here. So, Todd had asked how many people Texan Railroad staff each car, how many on each high rail crew. So
you always had a driver, you always had a chief operator, and you always had an operator at a minimum. Then you would have one of the rail guys, and then sometimes you would have somebody like me or who was out there to see what's going on, or you could have another mucky muck come out and see it. Plus you were always training new people. They had a lot of turnover. This was not for everybody. So getting trained people was important, and having them out there. When I was there were three bedrooms. So one guy was bunked up with another guy. My bed was, I was lucky enough to have the one bedroom. The only thing bad about my bedroom was that the tank that had all the waste was right under my bed. So they actually had to come in the window with the honeysucker and empty the retaining tank. So that was
that may be more technical information than we really needed here, Bob. So moving on. Rick asks, what happens to retired Sperry cars? And do you know of any efforts underway to preserve Sperry Car 127, the former Boston and Maine Railroad gas electric number 1151 and 151, built in 1926 by St. Louis EMC? Rick says he's seen internet photos of it on the Sperry scrap line near East St. Louis. It was reported to have been retired by Sperry about 2018. So that may be more than you're a little more current than you may be familiar with.
A little more current. However, I did say that 403 is going to the Danbury Railroad Museum when they can get somebody to actually drive it up there. So that's the Mack rail bus. They already have a Remington car up there, one of the Mack rail buses, but the Sperry 403, I rode that in the subways, and boy, was that cool to see all that 1910 construction. Just that was just fantastic for me. They do have 134 or 135 currently in the Danbury Railroad Museum. I know that that Tom DeJoseph had, he wanted to make sure that these things did get donated to museums. East St. Louis, yeah, that's where the other shop was out there. I don't know of any of what goes on today with the scrapping of these cars, but I did send you, and you could certainly share that roster of that drawing that has all the information on where the cars came from. But I can't tell you anything. That's from like 1995, and I put some marks on it on what happened with some of the stuff. But yeah, these cars are 100 years old now, some of them. So
wow. Okay, guys, moving on. Dave West, who in his career, I guess, knew about this sort of stuff, says that DHS stands for deep horizontal separation. But
okay,
for that. And Walter comments that Pandrol Jackson had some strange vehicles at their facility in Syracuse, New York. Do you have any idea what they were?
No, I according to Tom, Pandrol, which was Harsco, owned by Harsco, they were just looking to get out of the business. So it didn't take long for them to apparently back in 2002 make this happen. They used they're both in Danbury, and there's also another guy who builds trucks in Danbury. I can't think of his fellow's name, but you can see his trucks testing in the rail yards by the Danbury Railway Museum, and yeah, they used box trucks rather than the what Sperry was using with the Fords and the and the Sterlings. I don't know what they're using today, what if they've gone back to, what truck they're using now for their stuff. I just don't know. I know I've seen 950. There's a lot of new trucks, but I don't know what went on with a lot of the stuff when they combined and what they're doing now, unfortunately.
Okay. This is sort of in response to an earlier question. Dave West says, on commuter rail, testing was Wednesday to Sunday. On New Jersey Transit, all testing was at night when he was there. Thank you for that comment, Dave. Arthur asks, based on your past experience, do you think there is a role to be played in the future by photography drones for rail testing?
They can shoot lasers into the rail. I don't see where, the ultrasonics and the induction are both contact. And again, this is they're looking strictly at testing the rail. Drones for making sure that gauge is good and that there's a smooth rail, that there's not a kink, that there's not something, they don't detect, an elongation or something like that. Yes, but the actual rail inspection for defects, that's got to be done hands-on.
Well, we'll defer that question to future time with Marjorie Taylor Greene, since she's the expert on space lasers.
Okay.
Or maybe it's Lauren Bobert, I forget which. Okay, Alan from Pigeon Cove says, what's the requirement for frequency of testing? When he was working on the railroad, he was told that railroads that operated passenger trains had to be tested twice a year.
Twice a year, yes. Yeah, I was trying to look that up. Passenger railroads, Amtrak, commuter railroads, twice a year. It's other than that, it's based on tonnage ratings, and you have to go into the book to actually figure out what's required. The railroads, based on their tonnage loadings, have to make sure they get the testing done. If it's once a year for 40 megatons or whatever, that they get it done. Some railroads do their own testing. Union Pacific and BNSF, they have their own test vehicles, but they need to coordinate to make sure that they meet the FRA guidelines. I was going to put the FRA spec in there, but I did not. But if you Google FRA guidelines for rail testing, they'll come up with it, and you will see that I think 40 megatons, or whatever it was, has to be a minimum of once a year. If you get to 80, it's got to be twice a year, and passenger railroads are twice a year.
Okay. Kevin comments that he knows the MBTA does system-wide tests 4 times a year. I'm just going through some other things here. Steve comments that SRS is located in Shelton, Connecticut.
Shelton.
We have Matt comments that regarding the comments about testing in tunnels of the New York City subway, I've had the opportunity to ride the Transit Authority's current track geometry cars, and they're still by far the best view of the subway. Donald asks, is testing done on railroads of other countries besides the US and Canada? Presumably
yes.
By Sperry. Okay, yes is the answer to that.
That's where 200 went there. There were Spino and there were some other people that were doing it. Sperry was trying to push to get back into Europe. And at one time they had a car that did strictly Australia.
Okay. Marty asked, were there any special requirements and or work permits, work visas when Sperry inspection work by U.S. employees was being conducted in Mexico and Canada for the railroads?
I couldn't say. The guys in Canada, I know at the time, there was no big deal. The one thing I had to do for Sperry, for CP Rail, was they wanted the car detectors, the Ambler, when you would go past a car reader, Umler system. We had to put all of the RFD tags on the cars. We never had done that in the United States. It was only the cars going in Canada that had to have the RFD tags in so they could track their movement up in Canada. So I had to learn about the Umler system. And in fact, we became SRSX because we never had call letters because we never had a car in the system.
Huh. Okay. And finally, Todd asks or comments that the St. Louis facility is called Brooklyn.
Yeah.
And with that, we have come to the end of the comments, and we've come to the end of the Q&A. And on that, somebody asked, how accurate is the Walther Sperry car?
I will tell you. The Walther Sperry car is extremely accurate because Walther's contacted me, and I have that drawing up behind me, but I couldn't get anything newer. They actually went out and scanned the car, and that's how they got the dimensions. So the Sperry car that was done by Walters is very accurate.
I think it's funny because I interpreted the question. I chuckled because I interpreted the question as how accurately does it record defects in the rail? Presumably it's not capable of doing that. So anyway, hey, Bob, I just want to thank you for a fascinating presentation. And our attendance has dropped off a little bit, but we did have a extremely good attendance tonight. Very interesting and educational program. And I want to thank you again for making yourself available to put this on.